Okay, looking at polynomials of this form where a and b are reals. Oops, there's no a, so where b is real and t is in the real numbers. All right, so looking at this, just decide whether is there a zero vector. I can let b equal 0, but that still gives me p of t equal 1. That is not the zero vector, so there is no zero vector in this subspace. So I could be done. I could just do that and be done. Okay, I'm just going to continue on to show you what you also could do. So let's look and see if I was to take 1 plus bt squared, and then a q, 1 plus at squared, and add them together. So p of t plus q of t, 1 plus bt squared plus 1 plus at squared gives me 2 plus b plus at squared. This is not in the space, so it is not closed under addition, right? And that's because I'm supposed to have a 1 here, right? That's part of the criteria of what these things look like in this space. Okay, so I could be done, right? I could be done with that. Or I could look at what's happening with the scalar multiplication. So if I take my p of t equaling 1 plus bt squared, and I multiply it by a constant, I get c 1 plus bt squared, c plus cbt squared. This is not 1, right? So this is not 1, so it is not closed under scalar multiplication. So any one of these, right, would have been enough to show that it was not a subspace. This one or this one or this one. So this one fails on all criteria. All right, let's look at this one. So now we're looking at xy points in R2 where x's are bigger than 0 or bigger than or equal to 0 and y's are bigger than or equal to 0. So this space right here. Okay, so is there a 0? Yes, there is a 0, right? 0, 0 is part of this space because it's including the zeros. Okay, so check. If I take x and y, and I'm just going to make up different letters, x sub 1 comma y sub 1, right? So if I take those two things, x, y, plus x sub 1 comma y sub 1, and I add them together, x plus x sub 1 plus y plus, oops, sorry, not plus, comma there, y sub 1, this is in the subspace. So that stays inside. If I take any two things in here, take something in here and in here, add them together, they're going to stay in here. All right, so now let's look at the third one. So is it true that if I take any real number, remember it can be any real number, and I multiply it times my xy that's in my subspace, that I stay here? No. If I choose c equaling -2, then it's not in the subspace. So it is not closed under scalar multiplication. So it's not a subspace. All right, let's finish this page off with just this simple example. So this only includes the 0 vector. Okay, so is it a subspace? Well, it includes the 0 vector. Check. So if I take two things in here and add them together, 0 plus 0, do I stay in the subspace? Check, I sure do. And if I take my vector, the one vector that's in there, and multiply it times a constant, do I stay in the subspace? I do. So therefore, this yes is a subspace. The ultimate of trivial examples.